डॉक्टर बाबासाहेब आंबेडकर ओपन युनिव्हर्सिटी.
Namaskar dear students, I Dr. Himanshu Patel welcome you from the Chaitanya studio of Dr. Babasaheb Ambedkar Open University. In last lecture, we have discussed some of the important component of system programming. We have discussed two important component. One is macro in detail, we have discussed macro in detail, and second we have discussed loader and various types of loader scheme. In today's session, we will learn about microprocessor, internal architecture of microprocessor, what is bus system architecture of microprocessor, which includes address bus, control bus and data bus. We will discuss about in particular the architecture of 8085 Intel microprocessor, and in last we will discuss about SSI, MSI and VLSI, that is small scale integration, medium scale integration and very large scale integration. And we will also look at the history of microprocessor and microcomputer. So, let us start. The digital computer is based on the model input, process and output. The instruction or command are entered through input device such as keyboard or switch, and set of such instruction is known as a program, that we have already discussed. The set of program is called software and set of software is called package. Now, input is given by the computer, is processed by CPU, and whatever output is produced, the CPU sends output to the output device, which may be monitor, LCD monitor, or it may be LED also. Now, the timing of operation is controlled by control unit, that is why it is known as a control unit. The hardware constitutes physical component of computer and it deals with the discussion on microprocessor, that is our important. Now, we discussed about various components like memory. This is input, process and output. Now, let us look at the microprocessor basic function. Computer is defined as an electronic device that accepts data from input device. It is stored in memory or disk and display it on output device. Now, let us see basic block diagram of computer, and this is shown on your screen. For all types of computers such as personal computer, laptop, palm top, etc., the fundamental principle of working is same for all the type of devices. Now, as you can see on the screen, there are four main building blocks of computer: input, process, output and fourth component is memory. Now, data is inputted through input device such as keyboard, mouse. These are the example of input devices. Now, these input devices translate data and program that human being can understand into form that computer can process. The second part, CPU. CPU recognize processes binary numbers. The binary numbers are constituted from binary digits called bits. It is generally 0 and 1. So, bit are expressed as a 0 and 1. Now, how computer understands 0 and 1? The bits 0 and 1 are generated from low and high electrical voltage signal respectively. For us it is 0 and 1, but for computer 1 is a high voltage, 0 is a low voltage. Now, bit stored in digital electronic circuit is called register. To store 1 bit data, we require 1 register for storage. So, for 8-bit data requires 8-bit register for storage. Now, let us see from figure. Now, as you can see in the screen, CPU is the main component of computer or microprocessor system, and it comprises of three parts: ALU, register array and control unit, and we have input, output and memory. So, this is a block diagram of any microprocessor. Now, it receives instruction from keyboard and performs specific task. It communicates with IO device through bus and send the data between memory and processor and see how it produced output. Now, microprocessor is capable of performing computing functions and making decision to change a sequence of programming execution. The main parts of microprocessor are arithmetic device, arithmetic and logical unit or ALU, registers and control unit. Now, inside ALU there is a circuit such as half adder and full adder, subtractor etc., which is responsible for performing various arithmetic operations. Now, these circuits perform arithmetic operations such as addition, subtraction, complementing etc. ALU have logic circuits such as AND, NOT, NAND, exclusive OR gate, which performs logical operations. The data can be temporarily stored in the circuit called register that you can see here. The control unit comprises of control and timing signal. Now, let us discuss each of these. The first part is input. The input section of microprocessor mainly comprises of keyboard, teletypewriter and analog to digital converter, and there are two types of keyboard. One is called hex keyboard and second is keyboard that we are using called ASCII keyboard. The name indicates hex keyboard comprises of 16 numbers because hexadecimal consists of 0 to 9 and then A to F. So, hex keyboard has a 16 key. Now, it has a function key such as execute, store etc. Now, we have seen that hex keyboard in previous lecture. Now, we know that in standard keyboard we have many types of key like alphanumeric keys, function keys, toggle keys, special keys etc. Now, output, these section of microprocessor is connected with peripherals such as light emitting diodes, liquid crystal display, printers and CRT tube or cathode ray tube monitors. The 8085 microprocessor is connected to 7 segment LED display that we have seen in microprocessor kit. Now, third part is memory. The memory section of microprocessor is basically has two types of memory. We all know read only memory and read write memory or simply called RAM. The ROM comprises of stored program which we cannot change because it is a read only memory. Now, example of ROM is a monitor program. We have discussed briefly about monitor program. Monitor program reads instruction received from input, compares with standard set and provides equivalent binary code to the processor for execution. So, basically monitor monitors the entire activity of microprocessor. On other end, read write memory is user memory. User can save his program and data in read write memory or RAM, and content of RAM can be edited because it is a read write memory. The third important component is called system bus. So, basically bus is a wire which carries data and signals. So, there are three types of bus: address bus, data bus and control bus. So, you can see here this is a bus. So, bus carries basically either address for fetching data from memory, it may carry actual data for processing, and it can have control signals. So, basically there are three types of bus: data bus which carries data, second address bus which carries address of particular memory locations, and third control bus which carries control signal. Now, let us try to understand internal working of microprocessor. So, the instruction received from keyboard are stored in sequentially in the read write memory, and microprocessor fetches the first instruction, decodes and execute it. The sequence of fetch, decode and execute continues till the microprocessor come across an instruction which instruct to stop. So, until stop instruction is received, it continuously execute line by line or sequentially. Now, during the entire microprocessor use system bus to fetch the binary instruction and data from memory. It stores data in general purpose register temporarily. It performs computing using ALU, and finally, it sends out result in binary using system bus to 7 segment LED display. Now, how it works, let us try to understand step by step. So, here is a how it works internally. So, it is called internal architecture. The internal working of microprocessor system takes place as you can see on the screen. First, the 8-bit data is stored in the register. The arithmetic logic operation is performed as per command, and sequencing of execution of instruction is done, and finally, data is stored temporarily in read write memory during execution. So, this is how it works internally. Now, we have studied that system bus carries various types of signals. So, let us try to understand bus system architecture. So, you can see on the screen bus system architecture of microprocessor. Here we have three types of bus: address bus, data bus and control bus. You can see that address bus in yellow color, data bus in purple color and control bus in blue color, and it connects to various component like microprocessor unit, memory, input port and output port. So, okay, now let us see it detail in 8085 microprocessor architecture. Now, it comprises of three types of buses: address, data and control bus for timing. Let us try to understand address bus. The location of memory and peripherals are identified by placing a 16-bit address on address bus. The address bus is a 16-bit unidirectional bus, therefore, number of memory location will be 2 raised to 16 or 65,536, or we can say 64-bit KB. Now, these address line are identified from A0 to A15. The second is data bus. It is 8-bit bidirectional bus and it is identified by D0 to D7. Now, remember, data bus is bidirectional, address bus is unidirectional. The 8-bit data can be represented from 00 to FF, or we can number 256 numbers. Now, it is 8-bit microprocessor and it use 8-bit data bus. On similar line, if microprocessor use more data bits, then it is called that much number of microprocessor. For example, 8086 is example of 16-bit microprocessor. Why? Because it has a 16-bit data bus. So, basically the number of data size of data bus determine the size of microprocessor. If data bus is 8-bit, then we can say it is 8-bit microprocessor. If data bus size is 16-bit, we can say it is a 16-bit microprocessor. So, data bus is the number of bits microprocessor handle at a time, and address bus means how much memory location it can address. For example, we have 8-bit address bus, then it can only address 2 raised to 8 or 256 memory locations, and if address bus is 16-bit, then it can address up to 65,536 memory locations. Likewise, we have seen on the screen, it consists of interrupt control, serial IO operations, general purpose registers, stack pointer, program counter, incrementer and decrementer. We have decoder and encoder, we have instruction register, flag register, temporary register and accumulator. It has also arithmetic and logic unit that we have discussed, and there are timing and control signals like clock, read, write, status, direct memory access and reset. And we know that plus 5 volt represent 1 and ground represent 0. So, these are the two voltage level that 8085 understands. Now, it has a 8-bit internal data bus, and we can see there are 16-bit of address bus, and there is a control bus for handling various types of control signals. The Intel 8085 microprocessor was considered to be the first microprocessor released by Intel in late 1970s. It was the successor of Intel's 8085 microprocessor, and its features were increased, compatibility and much simpler voltage requirement. So, these are the improvement in 8085. This processor was mostly used as a microcontroller for many hardware applications. It consists of memory, which includes program, data and stack memories occupy the same memory space, and total addressable memory size is 64 kilobytes. The program memory, the program can be located anywhere in the memory. Jump, branch and call instruction use 16-bit addresses, and these instruction can jump anywhere within 64 kilobytes. All jump branch instruction use absolute addressing, that means static addressing. Now, let us see data memory. Data can be placed anywhere, as the 8085 processor always use 16-bit address, and there is a stack memory which is limited only by the size of memory. Stack grows downward. The first 64 bytes in a 0 memory page should be reserved for vectors used by reset instruction, and there are 5 interrupts in 8085 microprocessor that you can see on the top. The first is INTR, it is maskable 8080 compatible interrupt. In these, when the interrupt occurs, the processor carry out one of the instruction from the bus. Second interrupt is RST 5.5, it is again maskable interrupt. It allows processor to keep the data of PC register in stack, and its address is 2CH or 2C in hexadecimal. The third is reset 6.5, it is maskable and it keep data PC register in that stack with branches to 34H address. Next is RST 7.5, it is maskable and direct the processor to keep the data of PC register in stack and branches to 3C register. Trap is non-maskable, remember trap is a non-maskable interrupt and it receives the processor and save the content of PC register into stack and Now, when this interrupt is received, processor save the content of PC register into stack and branches to 24 hexadecimal address. Now, we have IO ports. There are 256 input as well as output ports, and now let us try to understand register. The first is accumulator. Here you can see accumulator. It is 8 bit that does arithmetic, logic and IO and load store operation. Now, before we understand flag register, we try to understand this general purpose register. So, here you can see general purpose register. These are general purpose WZ, BC, DE, HL, etc. These are called general purpose register. So, there is a 8 bit, there is 8 bit B as well as and 8 bit C registers are applied to make 16 bit BC register pair. You can collectively use it as a 16 bit data. In pair, C register has lower order byte, where few instructions are used by BC register and as a data pointer. Further, 8 bit D as well as 8 bit E register combines to form 16 bit DE register in pair. E bit has a low order byte and many instruction having DE register is used as a data pointer. Third pair is H and L. It is again 8 bit and it can be used as a 16 bit HL register pair, and when used as a pair, L register contains low order byte as usual and HL register usually contains data pointer to reference memory address. Below these is a stack pointer. It is a 16 bit register and its register is always incremented or decremented by 2. We have instruction register. Here you can see it stores instruction. It has all 8085 has all instruction with 2 new instruction from 8080. So, it has 7 processing register and register were 8 bit wide and had capability of performing 16 bit operation if they were paired together with other registers. Now, these process work by placing operating instruction in the first 8 bit register and additional instruction or execution data in the subsequent register space. Now, let us try to understand flag register in detail. So, here you can see flag register. We have C0, D0 to D7 to indicate 8 bit data, out of which only 5 are used. So, flag is 8 bit register that carries 5 bit flags. Now, what are that flags are? The first is S for sign. Now, it will set when most significant bit of the result is set. Now, what do you mean by this? Now, when we add two numbers and if result is positive, then most significant bit would be 1. So, this sign flag is set when most significant bit of the result is set. The second is 0, it will set when result is 0. If we are subtracting same number from original number, then result is 0. So, in that case this 0 flag is set and we can check whether this flag is set or not in program, and depending on that you can take decision, right. Then we have auxiliary carry. It will set when carry out of from bit 3 to bit 4 exist. So, this is called auxiliary carry flag. And we have parity. It will set when parity is even. So, last flag is carry flag. It will set when there was carry at addition or borrow at subtraction. Now, when you add two 8 bit numbers, the result may be larger than 8 bit. So, in that case this carry flag is set so that we can know that result is larger than 8 bit. So, there are 5 flags in flag register that you can use in program to check whether particular condition is met or not, like sign, carry, auxiliary carry, 0 or parity. So, this is how we can use flag register. Now, we have discussed about what is microprocessor, what is internal architecture of microprocessor, different types of buses. We have also understand the architecture of 8085 in detail. Now, let us try to understand terminology like small scale integration, medium scale integration and large scale integration. So, basically SSI, MSI and LSI and VLSI are emerged from the complexity of IC. It means the number of transistor of how many transistors are fabricated on chip decides the types of integration. The first integrated circuit contains only few transistors, so were called small scale integration. They use circuit containing transistors numbering in the tens, very few components are there. SSI was followed by the introduction of the devices which contains hundreds of transistors. Now, it scale goes up to 100. So, were called medium scale integration. MSI were attractive economically because which they cost little more system to be produced using smaller circuit board, less assembly work and number of other advantages. Next development was of large scale integration. Now, you can understand the development of LSI was driven by economic factor and each chip comprised tens of thousands, 10, 100 and now tens of thousands of transistor on a single chip. It was in the 1970s when LSI started getting manufactured in huge quantity. Now, these LSI was followed by very large integration or VLSI, where hundreds of thousands of transistors were used and still being developed. It was for the first time that CPU was fabricated on single integrated circuit to create a microprocessor. In 1986, with the introduction of first 1 megabit RAM chip, more than 1 million transistors were integrated. Now, microprocessor chips produced in 1994 contained more than 3 million transistors. So, it is called ultra large scale integration and corresponds to more than 1 million of transistor. However, there is no qualitative leap between VLSI and ULSI. Hence, normally in technical text the VLSI term cover also ULSI. Now, let us try to understand history of microprocessor. You can see on the screen. Now, semiconductor invented in the first integrated circuit in 1959, that makes microprocessor history. In 1968, Gordon Murray, Robert Noyce and Andrew Grove resigned from the Fairchild Semiconductor and started their own company. Today, we know that company as a Intel. In 1971, the first microprocessor Intel 4004 was invented. A microprocessor is also known as a central processing unit in which number of peripherals are fabricated on a single chip. It is ALU, control unit, registers, bus systems and clock to perform computational tasks. Now, let us divide this generation of microprocessor into 5 categories. The first generation was the period during 1971 to 1973 in microprocessor history. In 1971, Intel created the first microprocessor 4004 that would run at a clock speed of 108 kilohertz. With only 4 bit at the word size, the 4004 could only represent signed number in the range -8 to +7, which is indeed very small. So, it was not really of practical use for arithmetic calculation because of its very low range. However, it found application in controlling devices. Now, let us try to understand second generation. Intel 8008 was the next in the evolution. It is the first 8-bit microprocessor. This was in the year 1972. This was soon followed by Intel 8080, also an 8-bit microprocessor, and Intel 8080 was the first commercial popular 8-bit microprocessor. With 8-bit as the word size, it could represent signed number in the range of -128 to +127. This is also not good enough range for performing arithmetic calculation. It is very small range. Thus, 8080 also not used for only control application. Some other microprocessor like 6800 from Motorola, Z80 from Zilog were also popular at this time. Now, they were costly as they were based on NMSO technology fabrication and also for their super fast speed. Now, let us come to third generation. Around 1978, Intel releases 8086, which was the first 16-bit microprocessor. With 16-bit word size, it can represent number from -32,706 to 8 to +32,767. So, it becomes very popular not only for control applications, but also for number crunching operations. Speeds of those processors were 4 times better than the second generation processor. So, there is a huge increase in the speed of microprocessor. Not to be outdone, Motorola came out with 68000, their 16-bit processor. Zilog released Z8000, again a 16-bit microprocessor. These are the most popular 16-bit processor. Now, next is the fourth generation. In the early 80s, Intel released the 32-bit processor, the Intel 80386. With 32-bit word size, it was possible to represent signed number in the range ±2^109, which is a quite large range for performing arithmetic calculation. Now, if floating point notation is used, it can represent much large number. As such, these processors become very popular as the CPU in computers for numbering crunching operations. At this time, Motorola also come out with 68020, which is 32-bit processor, and Intel released 80486, which was basically 80386 processor, and 80387 on a single chip. Motorola released 68030 in the early 90s, and Intel released Pentium processor. It is exemplary last in performing arithmetic calculation and executing instruction. The Pentium 4 released in 2000, and it has 42 million transistor, worked with a clock frequency of 1.5 gigahertz and is rated for 1500 MIPS, million instruction per seconds. From 1995 to until now, this generation has been bringing out high performance and high speed processor that make use of 64-bit processor. This is called fifth generation processor. In present day, computers based on microprocessor are already faster than mini computers, and sometimes the mainframe computers of last earlier days, and they are available at a small fraction of the cost of such mainframe computers. So, in this session, we have discussed about what is microprocessor, what is the general architecture of microprocessor, what is the architecture of 8085 processor. We have discussed various parts of 8085 microprocessor like ALU, general purpose register, some special registers, buses, how much memory it can address, etc. We have also discussed about flag register, and in last we have discussed about important terminology like small scale integration, medium scale integration, large scale integration, very large scale integration, and we have also discussed about the history of microprocessor. Today's microprocessors evolves from very earlier how entire journey of today's microprocessor takes place, that we have discussed. I hope you enjoyed this session. Thank you and happy learning. स्वाध्यायः